Hello everyone, welcome to week 5 on practical math, looking at when graphs mislead us. Here's our essential question for the week. How do you know if a graph is misleading? Well, our objectives. We're going to be looking at the relationship between a country's real gross domestic product per capita and its standard of living. We're going to learn how to manipulate the units, scales, and origin in a graph to support a given statement. And we're going to analyze a graph to determine whether or not it is misleading. Again, take notes, pause this video at any time, work on your week 5 assessments. You can use this video as a text as a resource. Let me know if you have any questions or want help going over any of the assignments. All right, to get started thinking about things for this week, how do you know if you are healthy? What ways do we as human beings measure or take data about our health? Well, here's some things that come to mind. You may first check, do I have a fever? What's my temperature? If it's over 100 degrees, then it's a sign that, something's going on. You may check your blood pressure, check your cholesterol. There's all sorts of tests. You may decide, are you healthy based on your height or weight? Or are you a little overweight with your body mass index? You may look at what's your exercise. Do you exercise regularly? Do you eat healthy? These are all things we can measure to figure out, are we healthy? Well, just like we take data to measure the health of a person, we can also look at a variety of data to measure the economic health of a country. Let's watch a short video to start talking about how to measure a country's health.
When a doctor monitors the health of her patients, she measures vital signs: blood pressure, temperature, pulse rate. Similarly, when we wish to evaluate the health of the economy, we look at certain vital signs: the unemployment rate, inflation rate, and perhaps the most important, the growth rate of gross domestic product, usually called GDP. GDP is the market value of all final goods and services produced in a country during a given period of time, usually 1 year. A way to look at the health of a patient is to monitor the activity of the heart. One way to measure this is by an electrocardiogram, or EKG. An EKG readout shows how the heart is beating and how regular it is. Measuring the real gross domestic product over time gives us an idea of the health of the economy. There are several ways to do this. We can look at nominal GDP. We can take out the effects of inflation and look at real GDP. We can divide real GDP by the population to get real GDP per capita. We can look at the growth rate in real GDP. Each method tells us different things, but the growth rate in real or per capita real GDP probably tells us the most about our nation's health. Many economists and businesses keep an eye on real GDP to watch trends in our economy. In fact, one definition of a recession is a period of 6 months or more of negative real GDP growth. This would typically occur in the downward portion of a business cycle. Analysts also watch for real GDP declines to stabilize and then begin to rise again, signaling the beginning of an economic recovery. Real GDP is important because larger real GDP helps us to have a better life. But just as a good EKG readout is not a perfect measure of a healthy heart, real GDP is not a perfect measure of well-being. For example, real GDP does not measure the value of leisure, the value of goods and services produced and used in the home, or the quality of the environment. Although it's imperfect, real GDP does indicate a standard of living. Which of these countries do you feel have a higher quality of life? Why?
In the video, you were presented with this idea of standard of living. Standard of living is a measure of the goods and services available to each person in a country. It's a measure of economic well-being. We also call this per capita real GDP, and gross domestic product is what we mean by GDP. Per capita means per person. So when we talk about per capita real GDP, we're talking about how much do we produce as a country per person. So it's an average thing, it's a rate. Economists use a country's real GDP per capita to measure the standard of living. The higher a country's real GDP per capita, the better the standard of living because there are more goods and services available per person. A high GDP means you have access to a lot of healthcare, you have access to medicine, you have access to lots of supermarkets where you can buy all sorts of healthy food, you have access to exercise places, you can work but also take vacations. These are all things that a country with a high GDP has. In math terms, the two variables are related. Economists use real GDP per capita instead of nominal GDP per capita because real GDP per capita accounts for changes in production of goods, but not the changes in prices. Another way to say it is real GDP is adjusted for inflation. So when we compare dollars to now, 2016, versus back in 1976, we can compare the same thing. We're taking inflation into account. The real GDP per capita is calculated by dividing the real GDP, all that we produce as a country, by the country's population. We have about 300 million, 320 million people, so we would divide it there. All right, let's switch gears now and think about graphs. We're going to review looking at some graphs of economic data and learning how to read them correctly. First of all, a little bit about graphs. A good graph needs to have a title as well as labels and units on both axes. All right, so when we look at a graph, the first thing you're reading is what is this showing me? What is this measuring? What units? Is this clearly showing me what data is happening here? Graphs also need to have an origin and a scale for each axis. Here we go. We got origin point right there. And on a scale, it's a nice even interval. 0, 2, 4, 6, 8 goes up nicely. 0, 1, 2, 3, 4. They don't have to be the same scale, but they do have to be equal intervals. All right, let's look at some graphs and see if we can find all these things here. Here we've got a graph, the US real GDP, that's gross domestic product. So this is showing me how much the United States produced over these years, 1952 to 2009. And notice it's controlling, it's the real GDP, so it's controlling for inflation. It's telling you we're using $2005 for this whole range. All right, so it's got a good title. I feel like it's clearly telling me stuff. Let's look at the labels. Down here, there's no label, but it makes sense that we're going from 1952. These are years, all the way up to 2007. The scale, I would say, is a little off because I don't know what each little tick mark is representing. I can see 52, 57, 62, so it's going up by fives, but these numbers aren't lining up clearly with any tick mark, right? Are these twos? 2, 4, 6, 8, 10. Yeah, I would say these are probably going up by twos, but I can't really tell. It could be made a little clearer. On my y-axis, we have billions of dollars. What does that mean? So even though it shows $3,000 here, that's $3,000 in terms of billions of dollars. So actually it's 3,000 times a billion, which would make this $3 trillion. $6 trillion, $9 trillion. The US produces a lot, so we use some pretty big numbers, right? And I can pick some data points. I could say, okay, well, in 1952, our gross domestic product, the United States produced a little under $3 trillion worth of goods and services. But it's growing. There's little places where it's decreasing, and if I think about it, the red is usually a negative sign, a warning sign, a stop sign. The red here is indicating during these time periods, the economy, the growth of the economy slowed down or declined, right? The line is going down right there. It's going down right there. It's flatlining there, it's going down, it's flat, down, down. It's interesting here because it's still growing, but I think here it was growing fast and then it slowed and went fast again. So all the red lines, if I think about it, are showing me where the economy slowed down or declined. But from there on out, it's been growing overall. And right now at 2007, this is still 10 years ago, the economy, we were producing about 13.5, almost $14 trillion. So it's grown a lot over that 50-year period. There's a lot of information I can get from this graph, however, huh? Let's look at a couple other graphs. What is similar and what is different about these two graphs? Looking at the title, read real GDP per capita. Now I'm looking at per person in the United States. This one's also the same title. So they're both showing me the same thing, at least according to the title. This unit is 2011 US dollars, 2011 US dollars here, and years down here as well. What's different though is the scale. Here I'm going from 16,000 to 52,000, but here I'm going from 46,000 to 49,000. It's a smaller range. With my years, I'm going from 1960 to 2010 on this graph, but on this graph, I'm only going from 2006 to 2011. And in fact, if you think about it, this graph on the right is taken directly from this little portion right here. So if I just focused on this little window and then blew it up really big, that's how we got this graph right here. So they're the same data, but we're just focusing on the right on a smaller amount. We're not looking at all the years. We're looking at just a select number of years and a select range of values. All right. So there are some similarities, but there are some big differences in terms of what's showing. So if the two graphs show the same set of data, is one more useful than the other? Well, let's think about what we see here. On the graph on the left, my initial impression is, wow, look at what things have been doing. There is a lot of growth. I like that. It looks healthy. We have grown a lot in terms of our real GDP per capita in the United States. We have a healthy economy. But if I look at the right, oh man, we really fell off things. We have decline. And a little tiny bit of growth, but overall, a not healthy economy. So even though they're the same data, because I'm focusing on different parts, one is communicating something much different than the other one. The left one is useful if you want to show that things are healthy and there's a lot of growth. The right one, however, is more useful if you want to show things are not healthy and we're in decline. So again, same data, two very different graphs, two very different interpretations. So we can easily see from the previous comparison of two graphs, we need to be very careful about how we read them. It's easy to take data and create a graph to emphasize what it is you want to communicate. We're going to look at some other graphs that are now deliberately misleading and how they show data. Here's another one. All right, what have we got in this graph? Well, the title says supply of peanut butter candy bars. And here, down here, I got the quantity, 1, 2, 3, 4, 5, 6, 7. It's a nice even interval based on price. So we're comparing the quantity of price for my peanut butter candy bars. The axis here, all of a sudden I catch, look at this, 0, 2, 4, 8, 16. That's not even intervals. Well, how does that affect my graph? Let's try and use my graph to answer some stuff here. What does one candy bar cost? Well, right here, one candy bar looks like it costs $2. That's pretty fair, right? Better be a good candy bar, but that's what my graph is telling me. Two candy bars now, so let's find quantity of two, costs $4. Okay, well if one is $2, two must be $4. That makes sense. I would expect then to pay $6 for 3 candy bars, right? However, if I look on my graph, 3, right here, it looks like a nice even jump, but, oh, no, it's actually $8. That's a little misleading. It looks like it should be 6, but actually is 8. Well, what about 7? 7 candy bars all the way up here. If I extend my line out, this would be going from another jump. It looks like it's doubling. $128 for 7 candy bars? No, that's no good. Something's really messed up here. So what is wrong? There is a not equal intervals on my y-axis. So it is misleading. It looks like the price of candy bars steadily increases, but it actually is not. So to keep an eye out for misleading graphs, make sure there's a good title. Make sure the axes are labeled or that there are very clear units. Make sure the scale is not too large or too small. Make sure the scale has regular intervals. Make sure the intervals are equal. Those are all things to look at and are ways to make a graph misleading. Let's look at another misleading graph right here. We have a massive decrease in house prices. And when you first look at this, you're like, whoa, things declined a lot, right? This one goes up 4 lines. This one only goes up 2 lines. So it looks like, on first impression, between 2006 and 2007, house prices declined by half. Let's read a little bit more. Let's look at all the axes. This is showing the average house price. But my scale is really interesting on my Y values. I'm starting at 307,000 and going up to 312,000. That's not really that much. So this is saying, well, house prices here were 311,000 and they went all the way down, such a dramatic drop. They went all the way down to 309,000. Well, if you think about it, 311,000 to 9,000, there's really not that much difference. You're getting into hundreds of thousands of dollars. Losing 2,000 is not that much. That's like less than 1%. So really, the picture, they didn't use a good interval for my y-axis. If they had started at 0 and made these bars would have looked almost exactly the same. But they're trying to make a point. Whoever made this graph is trying to say there is a massive decrease. Look at this. So picture-wise, they're trying to make that point, but in reality, in the numbers don't seem to really support that. So what is misleading about this graph? They focused on a really specific y values. When they should have started at 0. Okay, here's another one. It's kind of misleading. This one's a little trickier. Here we go. We have solid waste generated. We can see over the years, there's millions of tons of waste, and looks like that we are increasing the amount of waste that we produce as a country. We are more and more wasteful. And it's going up from 500 up to 1,000. Well, a couple of questions I have when I look at this is, well, what waste are we talking about? Is this garbage, landfills? Is this radioactive nuclear waste? Is this, there's all sorts of things that could be wasted. Is this pollution in rivers? Is this biodegradable waste, or is this just plastic? Biodegradable. I feel like they didn't really very clearly tell me what kind of waste. It just says solid waste generated, but it doesn't say who generated, it doesn't say what, it doesn't say if it's the whole country, it doesn't say what type of waste. It's very vague. And to me, they just want people to think, wow, we're going off the charts with how much waste we're producing. But maybe we really aren't producing that much because they're not really clearly telling us what kind of waste or who is producing it. So it's misleading, and there's not enough detail in the title or in the labels of the axes. So to wrap it all up for that, be careful of who publishes a graph. Many instances when data becomes available, you'll see the same data presented in many different forms. Often those presenting the information have a particular point of view that they want you, the audience, to take with regard to the data. For example, if the federal government releases unemployment data, a news story can say one thing about the data, but a different news story could change something else. They can vary greatly in tone and content. One news story might say, wow, look at the increase or decrease from the previous quarter. But another one might show changes over the course of a decade. Let's play around with that idea a little bit. We're going to take the GDP of the US. So we've got a graph, website we're going to load up here, and we're going to take the data in the graph and make it fit this headline. We're going to say the country has the best standard of living in the world. So we need to generate our data and make a graph that seems to fit that. Let's go look at this website and try and make a graph showing that title. Okay, here I am. When graphs mislead us, here I have real GDP per capita. So again, how much do we produce per person in the US? It's a sign of economic health. We can see from 1965 all the way we're growing. We're much better off, at least per capita, than we were 50 years ago. So what we want to do, however, is adjust this, play around with our axes, and try and show that our country is producing the best in the world, that our country is growing amazingly well. Well, what I want to do is look at a period where we had a lot of growth and then just focus on that. If I look from here, from 2001 up to 2008, things were amazing. Look at that steep incline. That's a lot of growth. So I'm going to focus just on those years. I'm going to ignore these years here. Let's ignore all the way up through the 80s and all the way up to the 90s. We will start at 2001. And I want to ignore afterwards too. There's like kind of went down a little bit. So let's ignore all the way up from 2009 onwards. I want to show things are increased. Okay. Now I can also, it still looks kind of flat, right? It doesn't look that awesome, but if I focus on some Y values, let's ignore everything up to 120,000, right? And let's bring it down. Now I can make it look much steeper. Now I've got a graph that looks like, wow, from 2000 and 2008, these were our glory years. Look at, we went from $120,000 per person to producing $280,000 per person. That's a tremendous amount of growth. Our country is amazing. We have such a high standard of living. That's what our graph is now communicating and would support that title. Okay, now let's take the same graph, the same data, but instead make it fit this headline. This country's president should be impeached. Our GDP is at an all-time low. We need a new president with a new economic plan. All right, how do we take the same data and show that? Well, going back to my graph here, let's open back up the entire Y values. Let's open back up the entire X values. And now let's find a period where things were not very good, where there was a lot of decline. So there's some right around here, but there's a lot right around here. So I'm going to say, let's focus on this period in the early 90s when things really dipped, right? So I'm going to ignore the 60s and the 70s and the 80s. And let's just focus on that part right there. And I'm going to ignore all this other part where things grew really well too. We're just going to focus on this 4-year period. Now again, it's really flat, so let's adjust the Y values to make things look like they decreased really steeply. We're focusing in our data. We're trying to get a certain point made. And look at that. This now shows some data where you could say, oh my goodness, look at over this 4-year period. Look at what this president has done. They started in 1989 and things were okay for a little bit based on the previous president, what he did, of course. But once this president really got in office, things started to decline quickly, and it's just not good. We need somebody different. It's going to keep losing value if we keep with this certain president. So this is the same data, but showing a tremendous amount of loss, showing that we need change, and showing that, man, it's projected to continue to get worse unless we get something different going on. All right, so what did we do? We looked and talked about the country's real gross domestic product per capita. It's a measure of your standard of living and how healthy an economy is. We looked a lot at graphs, units, scales, origin, and learning how to read a graph, learning how you can manipulate a graph, and then becoming better at how to analyze a graph to determine what is this telling me? Is it misleading? Is it trying to make me think something? Is it a good graph? Hopefully this was helpful for you. Have fun working on this week's assignments, and I'll talk to you guys online.